All right, so angular velocity would be how fast the angle is getting bigger. And then we've got a few different angular velocity formulas. So when you look at this, I hope that you assume that this lowercase Greek letter that looks like a W stands for the angular velocity, and we call that omega. To get the angular velocity, we could take our angular displacement, which is theta, and we could divide it by time. So that would be radians per time. You could also take the arc length S, and divide that by the radius and multiply that by time, because S divided by R is omega from last section. So these two are the exact same formulas. You're just taking omega and dividing it by time. I said the wrong word. You're taking theta and dividing it by time. Sorry. Yes. And then the third one would be, if you already know the linear velocity, example miles per hour, if you already know the linear velocity, you divide that by the radius. And remember, the radius is length per 1 radian. If you divide the linear velocity by length per 1 radian, we can get the omega, the angular velocity. So there's 3 different ways we could get it. And those are all the same formula. They're just solved for different things or using different pieces of information. Calculate the angular velocity in radians per minute of a Ferris wheel, 250 feet in diameter, that takes 45 seconds to rotate once. Okay, I might start looking at, what am I asked to find? Angular velocity. So I'm going to be using one of these. So then what else do I know? What do I know? You mean my answer will be in radians? Oh, you looking right here? Yes, this is important that we notice that our answer needs to be in radians per minute. So when we've done all of our calculations, our units at the end should be rad per min. Remember, I talk about like canceling units out so they all work out. That's the units I should have when I'm done. So that's pretty important and helpful to me. What else do they tell me? They told me the diameter. Do I need the diameter? Do I need the diameter? I need the radius, maybe, perhaps. So radius is what? 125 feet per 1 radian. And then they tell me it takes 45 seconds to rotate once. What's that? What's my formula for theta? It has to do with time, but what's my formula for theta? What is it? Oh, that's one. This is one formula for theta. What's another formula for theta? Revolutions. 2 pi radians over 1 revolution. Okay. So what is 45 seconds to rotate once? What is that? What's it talking about? What's rotate once telling me? Say that again, Katie. Oh, how many times it goes around? Yeah. Is that important at all? Nah. What'd you say, Jen? No? Is the number of times it goes around important? For what? Revolution? So could I find theta? Can I find theta? What's theta? Oops, sorry, you couldn't see. 2 pi radians would be theta. I'm sorry, I pushed it down. I didn't realize I was way down there still. Okay, so I know theta. I know the radius. So I'm looking at my formulas above. I know that omega needs to be radians per minute when I'm done. Which formula could I use? What are we trying to find? Trying to find angular velocity. We need to get radians per minute. Do I need the length of the radius to find radians per minute? Do you know the arc length? The only time, well, I guess you could use, do we know the linear velocity? The line velocity? Do we know like miles per hour this thing's turning? Or I guess it would be feet per something. We do not know any of this information. All we know is this one right here. I mean, we know this information, but we don't know enough to use one of these. All we have to use is theta divided by time. So we're just going to take our theta, which is 2 pi radians, and we're going to divide that by 45 seconds. When I'm done, will I get radians per minute? I'm going to get radians per second. So now what we're going to do is we're going to use a conversion factor. We're going to use something that is equal to 1, but it's going to convert seconds into minutes. So I'm going to put seconds on top so that they will cancel out. I'll put minutes on the bottom, and you tell me what's equal there. 60 seconds to 1 minute. So that's how I'm setting up using my units so that I can get what I want when I'm done. So I'm going to get 2 pi times 60 over 45, and that will give me radians per minute. And let's go ahead and do the exact answer and the approximate answer. And yes, I will use my calculator. You too? You guys bring your calculator today? Good thing you're quick at math. You didn't bring one? You know I have a charger in the room, right? You have it with you right now? Okay. Well, you're sitting right by the plug. You're welcome. So my exact is 8 pi over 3 radian per minute. My approximate, if you guys need to see what's on my calculator, I can put it under there. My approximate is 8.378 radians per minute. So what was this diameter part doing to the problem? What's that thing called? Do you remember? They give you like extra numbers that you don't even need. Have you guys ever heard that term, a distractor? Have you ever had a problem where they give you extra numbers and you're like, I gotta use this 4 somewhere? But no, you don't. Okay. All right, the next one says find the angular velocity in radians per second of a wheel turning 25 RPMs. So RPMs is revolutions per minute. So find the angular velocity in radians per second. There we go. We have to find radians per second when we're done. So I'm going to try my first angular velocity formula, that is omega equals theta divided by r. No t, I mean that's a t, sorry. I looked at it too quick. Theta divided by t. Theta would be how many revolutions How many revolutions? 25. So theta is going to be here. I'll just set it up. 25 revs. Multiplied by 2 pi radians per 1 rev. And then we're going to take that and we're going to divide it by the time. And the revs per minute is 25 revs per 1 minute. That's what's given to us. That's not what we're going to find. That's what's given to us. So I'm going to multiply these together, and actually I'm going to wait to multiply them together, but I'm going to multiply them together, and you can see that the revs will cancel. You guys practiced with that already a bunch. You see that the revs can cancel, but do I get radians per second when I'm done? What am I going to get? Radians per minute. So I'm going to have to also do a conversion, and this could be a separate step. I like to try to do it in one step. You can make it a separate step if you want. I need to have minutes on top and seconds on the bottom so that the minutes will cancel. So how many minutes and how many seconds? 1 and 60. So multiply straight across. Looks like I get 50 pi over 60 seconds, which reduces to 5 pi over 6. Oops, I forgot my radians. Radians per second. So that would be the exact answer. And then the approximate would be 2.618. When we do have an assessment over this, you will lose points if you don't do your units. So make sure you're paying attention to that when you guys check your answers. If you forgot some units, put them in. Don't ignore it. I'm speaking about what I've seen in the past. So linear velocity is length. So now you can think of linear velocity being like if we're talking about a wheel and there's like one point on the wheel, we're still talking about length because we're talking about around that circumference and the speed that it takes to go around. That's not angular, that's linear because the circumference is length. So to get linear velocity, we take, and that's v, we take theta multiplied by the radius divided by time. So this is like the angular velocity, but just multiply by the radius. Okay? Example 3, we have a wheel of a truck that's turning at 6 RPS. What's RPS stand for? revolutions per second. The wheel has an 8-foot diameter. It's a big wheel. What is the linear velocity of a point on the edge of the wheel in feet per second? And what's the linear velocity in miles per hour? We have 2 questions. So we're going to do V. And remember, we want this in feet per second. And we're done. So what do I know? Remember, theta is number of revolutions times 2 pi radians over 1 rev. So we're going to put theta in. How many revolutions is it? 6 rev times 2 pi radian per 1 rev. We have to divide that by time. This is 6 revolutions per what? 1 second. And then we're going to multiply that by the radius. What is my radius? It's going to be 4 feet per 1 radian. Will that give me feet per second when I'm done? Let's see. The radians will cancel. The revs will cancel. Will I get feet per second when I'm done? Oh, I have no idea why I wrote 2 there. Because I guess I was thinking ahead to the next. I don't know. Before I got further in saying something. Okay, so I will be left with feet per second, so I'm going to go ahead and multiply this. It looks like, what do we got, 12 times 4? 48 pi feet per second. That's the exact answer, the approximate, just type in 12 pi, or 48 pi, maybe. And it's 150.8 feet per second. Question B says, all right, same question, only this time I want it in miles. I want it in miles per hour. So since we are using the exact same thing here, the exact same thing, I'm just going to pull this down, except I've already simplified. I'm going to pull down the exact answer, the 48 pi feet per second. Now we have to convert this. So in this information, there is a life skill that you should know. There's a few life skills you should know. How can we convert seconds to hours? Well, I'm going to have seconds on top. Do you have to go straight from seconds to hours? Can we go seconds to minutes and then minutes to hours? Can you go straight if you want to? If you know, yeah. Up to you. I'm just going to do the long way just for fun, you know. So if I'm converting this to minutes, I have 60 seconds per 1 minute. But then I'm going to convert minutes into hours. So that would be 60 minutes in 1 hour. So that will give me hours when I'm done. That's going to help me cancel out seconds, minutes, hours when I'm done. But I don't want feet, do I? I want to cancel out feet. What do I want to end up with? I want miles. So the other life skill, how many feet is a mile? You will not be given this information on a quiz or a test. You should know that there are 5,280 feet per mile. Okay, if you don't know, make yourself a flashcard. 5,280 feet per mile. Okay, then we can cancel out the feet. If I multiply straight across, that's going to be an ugly one. So I get 360 pi over 11 miles per hour, but that is approximately 102.816 mph. There we go. You guys are more than welcome to use your calculator. If you do not know how I got 360 over 11 on your calculator, or my calculator, I can go over that with you. Because I want you to be able to use your calculator to save yourself some time. All right, 2 more. A skater moves around the circle of a circular practice rink at a rate of 2.5, what's RPM? Revolutions per minute. The rink has a radius of 3.2 meters. It's 3.2 meters per 1 radius. What is the skater's linear velocity in meters per second? No, just kidding. Okay, so we're going to do linear velocity, and when we're done, we need to have meters per second. So linear velocity, how many revolutions? 2.5 rev, bless you, times 2 pi radian over 1 rev. We're going to divide that by time, which is minute. We're going to multiply that by radius, which is 3.2 meters per 1 radius. Let's go. And we look for everything canceling. The revs cancel. The radians cancel. I get meters per minute. Is that what I want when I'm done? So if that's not it yet, we're going to throw in an extra conversion. I need to cancel out minutes, and I want seconds when I'm done. So I have 1 minute per 60 seconds. That'll cancel my minutes, and I can multiply straight across. Can somebody validate that that is the right answer? They tried it and got the exact same thing. Did you try it, Peter? And then for the exact answer, not the exact, I mean the approximate answer, got about 0.838 meters per second. All right, very last example. A car is moving at a rate of 65 miles an hour and the diameter of its wheel is 2.5 feet. To find the angular speed of the wheel in radians per minute. What do we know about the car? How fast it's moving, which is what? 65 miles per hour. What does that mean according to like this vocab that we've been doing? What is this? This is the linear velocity. That's the linear velocity given to us. Do you think we need our diameter? No, we probably just want radius if we use it at all. Oops. Feet per 1 radius. We need to find the angular speed of the wheel. Angular velocity and angular speed are the same thing. You see the third one? Is take the linear velocity and just divide out the radius. So we take our linear velocity, which is 65 mph. Let me write it better. Miles per hour. And we're going to divide that by 1.25 feet per 1 radius. Instead of dividing by a fraction, I'm going to multiply by its reciprocal, 65 miles per 1 hour, multiplied by 1 radian over 1.25 feet. When we're done, we want radians per minute. Here's radians. Will I get per minute? Okay, so I need to get rid of what? Hours. I need to convert hours, right? And I need to not have miles or feet. So we'll do that second. So to convert to get rid of the hours, to convert to, what do we want, minutes? We'll just make a conversion factor where there's 1 hour and 60 minutes. So that is going to help me out of the, I just did it wrong, hours. I just crossed out the wrong one. No, I like you still. Okay. But again, we're going to have radians per minute, but we also have like miles and feet in there. So if I multiply by miles on the bottom and feet on the top, as long as it's a value of 1, we can do it. So how many feet are in 1 mile? So this is just like multiplying by 1. So you can do that there. So that'll cancel out the feet and the miles. We'll go ahead and use our calculator. 65, 280 divided by So you should get 4576. Who did not get that? There's usually ones that people type in their calculator wrong. No? No. It's usually people type in. So kind of alright. Because I guarantee that everybody else get 1647360. Anybody else get that? Some people are still working. People do this every single year. Can you guys help? So the calculator does order of operations. And so the calculator is going to go left to right. It's going to do 65 times 5,280, which we want. But it's going to take that answer and it's going to multiply by 60. But where was your 60 supposed to be? Is it supposed to multiply by 60? You're supposed to multiply the denominator by 60, right? So you either need parentheses, or if you just changed it to division, like if it's on the top, you can hit multiply. If it's on the bottom, you hit divide, and then it'll work. Okay? Yes? Yeah, that's fine too. I like doing less. All right, let's look at that last one. Find the number of revolutions per minute the wheels are rotating. So we need the RPMs. Revolutions per minute. The wheels are rotating. We know the angular speed. Why did I put that as theta? You guys yell at me, come on. It's omega. We know omega. We already know the angular speed. The omega is 4576 radians per minute. to get omega, one of these formulas uses revolutions in it. One of these formulas uses revolutions. Who said the first one? Why do you think the first one is correct? Why do you think the first one uses revolutions per minute? Because theta has revolutions in it. Okay? So we are going to use the first formula. We're going to do theta over time. So this is going to equal so omega is going to equal theta over time. My theta is number of revolutions multiplied by 2 pi radians per 1 rev. And then we have to divide that by time. So I'll divide it by minutes. Is an unknown. So instead of calling it hashtag, how about I just call it like X? How can I want to get rid of minutes. It's kind of like the furthest thing out. What could I do to both sides to get rid of minutes? It's just like solving an equation. It's divided. Let's multiply both sides by 1 minute. Both sides of the equation. When you multiply by 1 minute, they cancel. That's gone. If you need to rewrite it, we can. Oh, before I write it, those cancel. So I get 2 pi. What could I do to both sides to get it just X? 2 pi radian. So that'll cancel out the radians, cancels all that out. So basically I'm just dividing 4, 5, 7, 6. Let's see if we type this in our calculator correctly. It's approximately, I don't have an exact answer for this one. I mean I could, but it's approximately to 8.293 RPM. So if you type it in your calculator wrong, you're going to get it wrong. So make sure you know how to type it in your calculator. The worksheet attached, there's 2 worksheets attached. The worksheet attached, one of them should be this section, which is due tomorrow. And then if you're not going to be here tomorrow, we're going to review the 2 sections on Tuesday. So I gave you that worksheet as well.